In this problem, we're told an electric vehicle starts from rest and accelerates at a rate of 2 meters per second squared in a straight line until it reaches a speed of 20 meters per second. The vehicle then slows down at a constant rate of 1 meters per second until it stops. A says to find how much time elapses from start to stop, and B says how far does the vehicle travel from start to stop. So first, what I want to do is draw a diagram what's going on. So we have this car here, and so we know it's going to start from rest. So if something's at rest, it means it's traveling 0 meters per second. So it's going to start from rest, and then it's going to travel a little bit, right? It's going to be traveling or accelerating at 2 meters per second during this time. So 2 meters per second squared. And then it's going to reach a point, right? So like right here is the new car. And we know at this point, it's going to be 20 meters per second, right? Because it reaches this speed. And then we know it's going to then slow down at a constant rate. So it's going to travel some more. And it's going to slow down at 1 meter per second squared. So since it's slowing down, it's going to be -1, right? Because you're slowing at this, you're not speeding up. And then it's going to reach here, right? And so at this point is going to be where it stops. So it's going to be traveling 0 meters per second again. And so what we're trying to do is find how much time elapses from start to stop and how far it travels. So if we label this whole thing like this, right, I'm going to say t equals question mark because the total time it takes, we don't know. And then also delta x, which is how far it travels, we also don't know. So I'm just going to label it like that. And so now we can go ahead and try and solve. So let's go ahead and try and find, so we're trying to find how much time from start to stop. So we need to find how long this takes and how long this takes. And we have to split them up because the accelerations are different. So the formula you're going to want to use to solve this is v equals v sub 0 plus a times t. So let's go ahead and solve this for this part here. So what v is essentially the final velocity. So during this span, what's the final velocity? It's going to be 20 meters per second, right? Because at the end, this is how far or how fast it's going to be traveling. So it's going to be 20 equals the initial velocity. And we know in the beginning how fast it's traveling. It's not moving. So it's going to be 0 plus a. And so the acceleration during this time period is going to be 2, right? So a is 2 times t. So essentially 20 equals 2t. So if we divide by 2, t is going to be equal to 10. And it's going to be in seconds because we're using seconds, right? So t equals 10 seconds. So if I label this 10 seconds, and then let's try and find how long this takes. And we're going to use the same exact formula, do the same exact thing essentially. So v equals v sub 0 plus a times t. What's the final velocity here? So if we start here and we end here, the final velocity is going to be 0, right? Because it's going to a stop. So 0 is equal to the initial velocity. So in this interval, what is it starting at? We know it's going to be starting at 20 meters per second, right? Because it reaches the speed and then it starts slowing down. So it's going to be equal to 20 plus acceleration. The acceleration is -1 meters per second squared because it's slowing down at a rate of 1. So -1 times t. So it's just going to be 20 minus t essentially. So if I minus 20 from both sides, -20 equals -t. And then if I want to get rid of the minus sign, just multiply both sides by -1. 20 is going to be equal to t. And so it's going to be 20 seconds. So t equals 20 seconds. So this part's going to be 20 seconds, right? And if we want to find the total time, just add them up, right? So how much this time took, how much time this took. And so just 20 plus 10, it's going to be equal to 30. So 30 seconds is how much time elapses from start to stop. So this right here is going to be A. Let's go ahead and do B now. So B, we're trying to find how far it travels. So we're going to do the same exact thing where we split it up and solve for distance. So we have to do it 2 different equations because the acceleration is different. And so the formula we're going to use is v squared equals v sub 0 squared plus 2a times delta x. And so we know, we don't know all of these yet, right? We don't know delta x, but we know the acceleration, or at least in the first interval, right? Because we're starting with that one. So we know the acceleration, we know the initial velocity, and we know the final. So essentially all we have to do is just plug in. So the final velocity is going to be 20, right? Because at this point, 20 squared equals v sub 0, the initial velocity, which is 0, squared, plus 2 times the acceleration, which is 2, times delta x. And so we're trying to find delta x, right? So it's basically just going to be 20 squared equals 4x, or 4 times delta x. And so solving for delta x, you're going to get that it equals 20 squared over 4. If you go ahead and do that, you're going to get 100. And keep in mind we're using meters, right? Meters per second, so the distance is just going to be 100 meters. Now let's find the second part. So this is 100 meters. Let's do this part now. So it's going to be the same exact equation, just with a different acceleration, basically. So and the final velocity and initial velocity are changed, but just the same structure. So the final velocity, right, we're going to a stop, right? So 0 squared, which is just 0, equals the initial velocity, and we know here we're going to be traveling 20 meters per second, so 20 squared, plus 2 times a, and so the acceleration during this is -1, times delta x, so the distance during this. So it's basically going to be 0 equals 20 squared is just 400, minus 2 times delta x. So if I minus the 400 from both sides, minus 400 equals minus 2 times delta x. And then what you can do is just divide both sides by -2. And that's going to give you delta x. So delta x equals essentially just 400 divided by 2. The minus signs cancel. And if you do that, you'll get 200. So it's going to be 200 meters, right? Just like the last one. So 200 meters. So this distance right here is going to be 200 meters. And so if we're trying to find how far it travels total, so from here to here, we just add them up. So 100 plus 200, it's going to be equal to 300. And keep in mind we're using meters. So 300 meters. And so that's going to be your answer for B. And so yeah, hopefully you found this video useful.